Welcome to Haskell Field School. I'm Mike Osborne. I'm the Craft Development Specialist, and today we'll be looking at tilt-up wall systems and installation. For additional information on this topic, it can be found in our Pro Series textbook for formwork, Module 27310. For today, we'll be looking at the tilt wall process and going over the basics for this operation. All tilt wall jobs are not the same, and some are more complicated than others. The important takeaway for today is to get a general overview of the process so you can be better prepared in the field. Today objectives are: describe the tilt wall forming process, explain how to prepare a casting bed, identify the different methods of forming, discuss how architectural treatments are added to the wall panels, explain the purpose of reinforcement inside these panels, discuss how inserts and embeds are placed in tilt-up wall panels. Look how to install these panels safely and efficiently. After all, at Haskell, we want to do it right the first time. Tilt-up construction, by definition, is when concrete wall panels are cast in a horizontal position, either on the floor of a slab of a building or on a separate casting bed. Once these panels have reached 75% of their design strength, they are tilted up to a near vertical position by a crane and then moved to a desired location. But be careful. These panels can weigh on average 30,000 pounds, equal to the weight of 7 full-size trucks and 2 motorcycles. So watch your crush points out there. Today's highlighted project is the Large Mammal Project. This project includes steel wire fence line that will span across the property through forest and even through the bottom of lakes to create a wonderful habitat for these animals. The barn we are constructing will consist of tilt wall panels tied together with 5-inch HSS steel truss system for the roof, a stout structure to house these enormous mammals. Tilt wall projects can be very dangerous, so before any tilt operation, the job must undergo a hazard analysis. To recognize all the hazards associated with the operation, remember the focus 4: falls, caught in between, struck by, and electrocution. Always plan for safety, and always be on guard. There are a series of steps in the tilt process. First, you have to determine the erection sequence of the panels. Check the site and see what's the most logical approach. Determine the location of the casting beds. Place the concrete and allow to harden. Be sure you leave enough room on site to get equipment around. Lay out the panel dimensions and construct the edge forms. Insert any form liners or any other type of aesthetics that can be seen on the outside of the structure. Spray on 2 coats of release agent, and then place the reinforcement. Install any called out embeds, weld plates, lift inserts, or brace inserts that are on your plans. Now you can place the concrete. Strip the formwork and locate, lift, and brace inserts and remove pocket formers. Install braces, lifters, and ground release devices. Then go out to the footer and place the shims and the guide dowels. Finally, you can erect the panels when the concrete reaches 75% of its design strength or greater, and brace it in plumb position as per your plans. Let's begin planning the sequencing of our operation. First, let's pull up the structural drawings and look for how many panels we will be placing. Access for the crane will be coming in on the west side of the building, and for this operation, the crew has decided to begin from the southwest corner of the structure and building counterclockwise. With this information, we can now properly lay out our casting beds in a location that provides the needed access for equipment. Here we can see that we need a total of 3 casting beds. Since the crane will be accessing on the west side of the barn, our casting beds will be on the north, south, and east sides of the building. We have to make sure we add the dimensions of the panels correctly and leave enough room for formwork and supports. Double check the crane specs to be sure you have enough room for the operation before we place the casting bed. To begin our formwork, we find our information for the formwork and dimensions on the structural plans or TP plans. This is why having a sequence plan and enough room for equipment between the casting bed and footers is so important. Panel formwork must always be laid out with the crane operation in mind. Access is everything. The plan for this operation is to start lifting with panel E1 and working counterclockwise, lift each panel one after the other, completing the operation with panel A1, making a loop around the structure's footing. Remember, these panels approximately weigh 30,000 pounds. The less time in the air gives us less chance for an incident. Forms used to cast tilt-up panels primarily are edge forms, like those used for slab-on-grade work. When wall thicknesses are greater than 10 inches, plywood form panels can be used instead. Forms may be supported in a number of different ways, including the use of wood cleats or plastic supports. Windows and doors are created in tilt-up panels by blocking out the openings in the form. Cleats are placed inside the opening. Sometimes spreaders should be used to prevent larger frames from bowing in. When door or window frames are used as blockouts, make sure the edges of the frames are protected. After edge forms are completed, we'll begin to add aesthetic features to panels using form liners and reveals. These will be found in our architectural plans. Notice how all the plans call out both type of liner and depth. Now let's go to the tilt-up details page to get a better visual looking at the cross-section views. Now we know each edge gets chamfer and what size, along with the gap size between the panels, sealant installation, and depth of reveals. Using these cross sections are necessary for you to get a better mental image of what you are forming. Release agent is a liquid substance sprayed on edge forms, casting bed, reveal strips, and form liners to allow forms and panels to be removed easily. Always spray 2 applications. Never spray on rebar or embedments. Rebar, or welded wire fabric, is placed in the forms after openings, decorative features, reveal strips, insulation, and form liners are in place and before the concrete is placed. Although reinforcement is needed for the fabrication and strength of the panels, the amount of the reinforcement is more to limit the cracking of the panels when they undergo the immense amount of stress and bending when they are lifted. The engineer may require additional reinforcement to compensate for the lifting stresses. If there are openings, the lift may require a strong back. In this video, you can see the bend in this panel during an edge lift. For this reason, we only lift small panels by edges with engineer's approval. Right now, the only thing preventing the panel from breaking is the tensile strength provided by the rebar, but eventually the weight of the panel is too great and it breaks. Follow the plans closely and use the right lifting process for your panel. There are several types of embeds in the tilt wall panel. Although we usually consider the weld plates as embeds, remember anything placed inside the concrete is considered to be embedded inside the concrete. Some structural embeds or embedments used for the erection process include beam pocket liners, weld plates, attachment plates, support angles, brace inserts, and lifting inserts. Some of the architectural features that are embedded in the wall will include ridge form liners for insulation, veneers, decor form liners, and other aesthetics. Inserts and embedments must be properly positioned inside the forms and form edges as per plans and specifications. Placement of embeds can be found in the structural drawings, coordination drawings, and erection manual. It is always best practice to look at all the drawings and verify the dimensions of the embedments before placement of the embeds. Let's look at panel D2. Here on our coordination drawing, you can see that our team has already vetted through the plans to help our field team lay out the embeds and inserts quickly and accurately. Elements of the panel are even color-coded with dimensions measured from inside the formwork to the center of the embeds. They also found upcoming items that could be problematic. These will be questioned in an RFI and sent out to engineers to see what inserts can be moved to protect the reveal. There are many types of inserts. Let's look at the most common ones. Your drawings and specifications will have the appropriate inserts already picked out for you. To lift and place panels, we need the lifting and a bracing insert. The brace insert has wire legs welded to a coil with disposable plastic plug with antennae to locate the insert after concrete placement. The wire legs have plastic feet to prevent corrosion at the concrete face, and the number and location of brace inserts will vary on the dimensions of each tilt-up panel. The lifting insert is designed for tilt lifting panels. The insert develops a high pull-out strength for the lift and also has integrated plastic former with antennae to identify its location after placement. Once the disposable former is removed, the lifting insert is exposed and the clutch can be installed. The clutch connects the tilt-up insert into the crane rigging and lifts the concrete panel from the casting surface. The ring-shaped hook securely into the loop of the insert for lifting and handling. The design of the lifter discharges the lateral forces of angular lifting directly into the tilt-up panel. Once lifted and braced in position, the lifter can be safely removed from the ground. All erection calculations are performed under their direct supervision and reviewed by the professional engineer and is communicated in the panel book with all the information you need to perform this operation. Some panels have a lot of openings that cannot support its own weight during the lifting process. Strong backs are used to reinforce these critical areas of the panels during erection. As a guideline, when you have any dimension that is less than 2 feet or a panel thickness less than 7 inches, a strong back is recommended. Notice that the inserts for the strong backs are the same as the bracing inserts. Look on your plans and make sure they're in the right location. In some cases, lifting inserts cannot be found or may become unstable. We will then need to notify the engineer for a location to install an emergency lifting plate. This is not preferred lift and is not considered to be a best practice. This lift is now critical because the chance for an incident has grown considerably. Always quality check for inserts and other embedments before placing concrete. Before we lift the panels, let's take a minute to talk about safety. Due to the immense weight of these panels, there must be a quality check on all components before lifting. Can you imagine a damage one would receive if struck by one of these panels? Always quality check your inserts and clutches for any instability to make sure all clutches are fully engaged in the buckets. Let's look at what happens when a crew lets their guard down and there's a rigging failure at the clutch location. Tilting panels is one of the most dangerous jobs we have on site. With all the variables of what could go wrong, we need to make sure that all lifts are performed as directed in the panel book. The panel book is a necessary guide provided by the engineer to ensure we are lifting and securing the panels efficiently and safely. The panel book will be approved and reviewed by our staff to ensure that all dimensions, weights, and inserts match our structural, tilt panel, and coordination drawings. Make sure you look for this stamp before you use this book. In this book, you'll find necessary information for your operation. Information you will need will be warnings, general notes, a layout key with symbol legend to help you navigate through the drawings, details on the types of hardware and inserts used, and a rigging page to show you the configuration of the slings and instructions for bracing the panels. Now is a good time to pause the operation and huddle to get our heads in the game. Conditions have changed slightly, so let's recognize the current hazards of our operation. Falls. Mobile work platforms are being used to attach the braces, so we need to be sure our craft is tying off with the right gear. Caught in between. Now that we have more equipment in play, creates more caught between situations, not to mention getting your hands caught between the panels during installation or between the basket and the panel while working. Struck by. There are several struck by hazards, being hit by the panel, equipment, or tools being dropped from the man lift. Electrocution. Check the site again for any electrical lines. Not all lines are overhead. Look down on the ground and make sure there's no power cords leading into the building. Make sure your site is safe before any operation. Time to rig these panels up. For this lift, we are renting the rigging equipment from a crane company. Remember, there's a lot of heavy components here, so we must watch all our crush points. Getting the rigging off the truck is an operation in itself and must be done systematically. We don't want anyone getting hurt. First, our team takes off the major spreader bar and using the panel book aligns the distance of the eyelets to the called out dimensions on the specific panel page. Now that the major spreader bar is ready, let's pick up the spreader sling and pulley. Just because this equipment is rented, we can't assume that it's all been inspected. Take the time to inspect all the rigging. Certified riggers will look for any damage and proper tagging on all devices. If you see something, say something. The life you save may be your own. Once the rigging is in place, quickly tighten up the lines for a final check of the rigging system. Looks like we have a shackle facing the wrong way. Let's get it back in position and it's time to fly. Remember to have good housekeeping and always clear path for this panel. Each lift should be discussed before lifting and all tools and materials should be ready to go. Now that the panel is up, time to brace the panel into position, and once it's secure, we can finally remove the clutch. There are three types of braces. Adjustable pipe braces are telescoping pipes that come in various dimensions. They can range from 7'6" to 40 feet. Pipe braces have a fixed length. They can come in ranges of 16'6" to 32 feet 3. Heavy-duty pipe braces have a larger diameter than the other two for a greater capacity. All of them have an 18-inch threaded rod for adjustment and connecting shoes for anchoring. Going back to our panel book, we can see the engineer also has instructions for bracing. Not only do we have to be specific with the locations of the braces on the panel face, but we also need to know what we are bracing to. Most panels are braced to an already placed slab, or SOG, slab on grade. These techniques make it easy because there's a lot of real estate to choose from, and as long as you stay within 5 degrees of plumb and the slab in that area is thick enough, you can support the brace. However, here at Large Mammal, we have a hardy truss system and cages to corral the mammals inside the building, so we're going to have to brace these panels from the outside. This will require additional planning and layout, and the engineer has already given us two choices. A deadman is a type of false work that is temporary and can support various structural elements to a desired load. The design and tabulated loads will be communicated by the engineer. In this video here, we're looking at a regular slab-on-grade installation where we're installing the bottom of the brace with a specified anchor and fixing that brace into position. Installation of the brace into a deadman is no different, except in this case the engineer has detailed out a brace insert to be embedded in the deadman during installation. This will result in no drilling of the deadman. We can simply bolt the base of the brace just as we did the top and the face of the panel. You may have seen other types of deadmen that are above ground. These usually handle smaller loads, and they're usually used to brace up vertical formwork. Because of the cost and the lengthy process of having to cast and place all those deadmen around the building, we have decided to go with the Brace Badger. The Brace Badger is considered a drillable pile that can support high loads. This process is much more cost-effective and requires less equipment and manpower to install. Once we install this as manufacturer's instructions, we can connect the brace to the Badger and plumb up the wall. After one more inspection of the braces, we can now take the load off the crane and release the clutches by pulling the rope attached to them. Now we can start the process all over and install the next panel. Good luck out there, and remember, safety first, watch out for each other, and good luck.